The Boeing AH-64 Apache is an American twin-turboshaft attack helicopter with a tailwheel-type landing gear arrangement and a tandem cockpit for a crew of 2. It features a nose-mounted sensor suite for target acquisition and night vision systems. It is armed with a 30mm M230 chain gun carried between the main landing gear, under the aircraft's forward fuselage, and 4 hardpoints mounted on stub wing pylons for carrying armament and stores, typically a mixture of AM-114 Hellfire missiles and Hydra 70 rocket pods. The AH-64 has significant systems redundancy to improve combat survivability. The Apache began as the Model 77 developed by Hughes Helicopters for the United States Army's Advanced Attack Helicopter Program to replace the AH-1 Cobra. The prototype AH-64 was first flown on 30 September 1975. The U.S. Army selected the AH-64 over the Bell AH-63 in 1976, and later approved full production in 1982. After purchasing Hughes Helicopters in 1984, McDonnell Douglas continued AH-64 production and development. The helicopter was introduced to U.S. Army service in April 1986. The advanced AH-64D Apache longbow was delivered to the Army in March 1997. Production has been continued by Boeing Defense, Space and Security, with over 2,400 AH-64s being produced by 2020. The U.S. Army is the primary operator of the AH-64. It has also become the primary attack helicopter of multiple nations. The AH-64 Apache has a 4-blade main rotor and a 4-blade tail rotor. The crew sits in tandem, with the pilot sitting behind and above the co-pilot gunner. Both crew members are capable of flying the aircraft and performing methods of weapon engagements independently. The AH-64 is powered by 2 General Electric T700 turboshaft engines, with high-mounted exhausts on either side of the fuselage. Various models of engines have been used on the Apache. Those in British service use engines from Rolls-Royce. In 2004, General Electric Aviation began producing more powerful T700 GE701D engines, rated at 2000 for AH-64DS. The crew compartment has shielding between the cockpits, such that at least one crew member can survive hits. The compartment and the rotor blades are designed to sustain a hit from 23mm (0.91 in) rounds. The airframe includes some 2,500 pounds, 1,100 kilograms of protection, and has a self-sealing fuel system to protect against ballistic projectiles. The aircraft was designed to meet the crashworthiness requirements of MIL STD 1290, which specifies minimum requirement for crash impact energy attenuation, to minimize crew injuries and fatalities. This was achieved through incorporation of increased structural strength, crash-worthy landing gear, seats, and fuel system. On a standard day, when temperatures are 59 degrees Fahrenheit, 15 degrees centigrade, the AH-64 has a vertical rate of climb of 1,775 feet per minute, 541 meters min, and a service ceiling of 21,000 feet, 6,400 meters. However, on a hot day, when temperatures are 70 degrees Fahrenheit, 21 degrees centigrade, its vertical rate of climb is reduced to 1,595 fpm, 486 meters min, and the service ceiling is reduced to 19,400 feet, 5,900 meters, due to less dense air. One of the revolutionary features of the Apache was its helmet-mounted display. The integrated helmet and display sighting system among capabilities. Either the pilot or gunner can slave the helicopter's 30mm automatic M230 chain gun to their helmet, making the gun track head movements to point where they look. The M230E1 can be alternatively fixed to a locked forward firing position or controlled via the target acquisition and designation system. On more modern AH-64s, the TADS PNVS has been replaced by Lockheed Martin's Arrowhead targeting system. U.S. Army engagement training is performed under the Aerial Weapons Scoring System integration, with Longbow Apache Tactical Engagement Simulation System, using live 30mm and rocket ammunition, as well as simulated Hellfire missiles. The Smart Onboard Data Interface Module, SMODEM, transmits Apache data to an AAS ground station for gunnery evaluation. The AH-64's standard of performance for aerial gunnery is to achieve at least 1 hit for every 30 shots fired at a wheeled vehicle, at a range of 801,200 meters. In 2014, it was announced that new targeting and surveillance sensors were under development to provide high-resolution color imagery to crews, replacing older low-definition black and white imaging systems. Lockheed received the first contract in January 2016, upgrading the Arrowhead turret to provide higher-resolution color imaging with longer ranges and a wider field of view. In 2014, the U.S. Army was adapting its Apaches for increased maritime performance as part of the Pentagon's route balance to the Pacific. Additional avionics and sensor improvements include an extended-range radar capable of detecting small ships in littoral environments, software adaptations to handle maritime targets, and adding Link 16 data links for better communications with friendly assets. The AH-64 is adaptable to numerous different roles within its context as close combat attack. In addition to the 30mm M230E1 chain gun, the Apache carries a range of external stores and weapons on its stub wing pylons, typically a mixture of AIM-114 Hellfire anti-tank missiles and Hydra 70 general-purpose unguided 70mm rockets. An 18-aircraft Apache battalion can carry 288 Hellfire missiles, each capable of destroying a tank. Since 2005, the Hellfire missile is sometimes outfitted with a thermobaric warhead. Designated AIM-114N, it is intended for use against ground forces and urban warfare operations. The use of thermobaric enhanced blast weapons, such as the AIM-114N, has been a point of controversy. In October 2015, the U.S. Army ordered its first batch of advanced precision kill weapon system guided 70mm rockets for the Apache. Following the cancellation of the AH-56 Cheyenne in 1972, in favor of projects like the U.S. Air Force A-10 Thunderbolt II and the Marine Corps AV-8A Harrier, the United States Army sought an aircraft to fill an anti-armor attack role that would still be under Army command. The 1948 Key West Agreement forbade the Army from owning combat fixed-wing aircraft. The Army wanted an aircraft better than the AH-1 Cobra in firepower, performance, and range. It would have the maneuverability for terrain following nap of the earth flying. To this end, the U.S. Army issued a request for proposals for the Advanced Attack Helicopter Program on 15 November 1972. As a sign of the importance of this project, in September 1973 the Army designated its 5 most important projects as the Big Five, with the AH included. Proposals were submitted by Bell, Boeing Vertol Grumman Team, Hughes, Lockheed, and Sikorsky. In July 1973, the U.S. Department of Defense selected finalists Bell and Hughes Aircraft's Tulco Aircraft Division, later Hughes Helicopters. This began the Phase 1 of the competition. Each company built prototype helicopters and went through a flight test program. Hughes Model 77 AH-64A prototype first flew on 30 September 1975, while Bell's Model 409 AH-63A prototype first flew on 1 October 1975. After evaluating the test results, the Army selected Hughes AH-64A over Bell's AH-63A in 1976. Reasons for selecting the AH-64A included its more damage-tolerant 4-blade main rotor, and the instability of the AH-63's tricycle landing gear arrangements. Boeing has suggested that the AH-64 could be fitted with a directed energy weapon. The company has developed a small laser weapon, initially designed to engage small UAVs, that uses a high-resolution telescope to direct a 210 kilowatts beam with the diameter of a penny out to a range of 5.4 mi on the Apache. The laser could be used to destroy enemy communications or radio equipment. On 26 June 2017, the Army and Raytheon announced they had successfully completed the first ever helicopter-based flight demonstration of a high-energy laser system from an AH-64.